Hello everyone. Now let's work on LeetCode hard problem number 1444. Number of ways of cutting a pizza. So this is an interesting question because it says cutting a pizza, but actually there are a lot of apples here. I don't think any pizza has these apples on it. Anyway, let's see what this question is about. So we are given a rectangular pizza represented as rows times columns matrix. And every position, there's either a dot or an apple. It's represented by letter A. Okay, then we can cut this pizza by either horizontally or vertically. Okay, so you need to make sure that after you cut, there is at least one apple. One apple either in the slice you cut, or and also as a slide that are left over. So every time you make a vertical or horizontal cut, the pizza will belong to you, or the left one is the one on the right bottom corner. For example, if you cut this way, the bottom part will be left. If you cut this way, the right part will be left. And the question asks, given these rules, how many ways can you cut this pizza? And the column and rows are 50. So this is not a very huge number. However, you cannot do just naively search for all possibilities. And k is larger than 1, and less equal to 10. Okay, so how to solve this problem is actually we need to find a way to represent the state, right? That is a key point to solve this problem. So remember that we are always having the right side or the bottom side, so that this point is fixed, right? So then the rectangular is only defined by the top left point. So only the top left point is something we need to consider. So that means we can use Fij to represent the rectangle we are going to cut, where Ij is the top left, it's on the ith row, and j's column, right? And there's another variable, means how many cut we need to do for this slide. So we have another variable. So we have Fijk. It means for rectangle Xij, cut k times, cut k minus 1 times to k pieces, the number of ways. Okay, so if we have this information, we can actually use DFS to solve this problem. Let's first define these states here, and of course we need to initialize it. I usually initialize it immediately after the definition, so that I will not forget. So this is f, and let's save this pizza to a global variable, pizza. Okay, so pz equals pizza. So we can use this value anywhere. And I think that's it. Let's write this DFS function. DFS has the I is 0, 0, and k, right? We need k pieces. So DFS is with the u, v, and k. This means row u, column v, k pieces, the number of ways. So if k equals 1, then we'll just return 1, right? And do not forget that we need to check there's no apple left, where there is at least one apple inside this rectangle from UV to bottom right corner. So if not has apple, U and V will return 0. And so we need this function has apple. We'll implement it later. Okay, then let's implement the DFS first. So now we have k equals 1, then we return 1. If k is not equal to 1, we iterate every possibility to cut. First, cut horizontally, so rows. Okay, so for int I equals u, I plus 1 less than pizza size plus I. And we need a flag to check whether the part to be cut has apple or not. Okay, so we need some way to check the flag. Then if flag, we can add this DFS I plus 1 V k minus 1 into the RES. Okay, so we will define RES here. So cut horizontally is here. Okay. Then we will do the check for flag. I think somewhere here. Use some pre-calculated matrix for this number. Oh, I forgot. Fijk is actually 55, 55, and this is 10 at most, so we put 12 here. Okay, so we will need to calculate row. So memset row 0 size of row. Okay, so for int I equals 0, I less than pz size plus I. Then for j, we check from the last column first. So pz j equals pz I size minus 1, j greater than 0, minus j. If j equals pzi size minus 1, so this means row is just equal to whether pzij equals a. Okay, if not, row equals to pzij equals a or pzij plus 1. This is for row, and very similar for column. We'll write it here. We also need to check for column. So we replace everything here to column. Row, column, G. Okay? So we need to change I and J. This is PZ0. Okay? And this is J. And this is I. Right? This is J. This is PZ. This is I. This is I. So if I equals PZ size minus 1, this is IJ, and I plus 1, J, right? So let's make it clear. Column IJ means at ith column at j's column from row I to row size -1. There is an apple or not. Okay, this is for column ij definition. And for row ij, we have the same definition. At ith row from column j to row I size -1, there's an apple or not. Okay? This is column. Okay, so we're checking if there's a so this is PZI, right? And I think this is PZ size. Okay, we are just checking. For example, this is a row. We are checking from here to the end if there's an apple, and column is from this position to the end to the bottom whether there's an apple. So if we have those information, we can easily check for flag here. So this is cut horizontally, so we check row from I and V. If this is 1, then flag is true, okay? And then we will cut vertically columns for int j equals v, j plus 1 less than pz 0 size plus j. If column uj, then flag equals true, okay? And if flag, we can put line 54 here, okay? And this is I, this is v plus 1. No, this is v, right? This is u, this is j plus 1. And the whole thing should be modular by m. And we'll define m here. So m equals 1 plus 7. Then we just return res. We haven't used this memorization. Let's first see if the algorithm is correct or not. So let's see, 19. Okay, row ij, right? This is also ij. And this is ij. And this is ij. So the answer is not correct. Let's see what's happening. So in order to debug, I think first let's check whether these are initialized. Okay, they are initialized. PZ is pizza. And we will check if these are correct. I think we didn't update flag, right? Flag should be reset to false. Let's see. It's still not correct. So let's check for more. so this is I equals, let's read this DFS again. So DFS has three inputs, U, V, K. So if has apple, oh, we forgot to implement this has apple function. So for I equals UI less than PZ size plus I, for int J equals V, J less than PZI size plus J, if PZIJ equals A, then we can return true, right? Otherwise, we'll return false. Let's see. Still not correct. So the answer seems to shift it by 1, right? So let's check again. So we have, if there's no apple, then we return 0. Otherwise, if k is 1, we'll return 1. And we have a return variable. And this flag is set to false. And m is 1 in 9 plus 7. Let's see if it is 1 in 9 plus 7. Okay, 1 in 9 plus 7. Then first we see if we can cut horizontally. So I equals u, and I plus 1 less than pz sine plus I. So if for this row I and v, the flag is true, flag will be set to true. And if flag, so we do another DFS. It's I plus 1, v, k minus 1. Okay, this seems correct. And for the cut vertically, j equals v, then j plus 1 less than pz 0 dot size and plus j. And if column u, j, so this is u, this is, we want to know whether from on the u's row until the end, if there's an apple, uj, then flag is true. And if flag, we do another DFS, it's u and j plus 1, k minus 1. Okay, then let's see has apple function from u until the end of this row, from v until the bottom. If pzij equals a, return true. Otherwise, return false. This seems correct. Let's see about this part, pre-calculation of row and column. So we have I equals 0, I less than pz size, and j is looping backward. If j equals the last element, it is just if this is equal to 1 or not. If this is 1, then we set it to 1, otherwise it's 0, okay? Now it's 1 or 0. So, and if this is a, or ij plus 1 is a, ij plus 1. Oh, I think this is row, right? And this is column, okay? Let's rerun. Yeah, it's accepted. Let's submit. I think there will be a time limit exceeded because we haven't added the cache. So the cache is already initialized. So let's just directly add it. So we add it here. So if f u v k is larger or equal to 0, which means it's already calculated. So we just return it. And at the end, f u v k equals res. Okay, let's try. Let's just use this test case. Okay, it seems the speed up very obviously. Let's see if it can pass. Okay, it's accepted. And I think you can further speed up if you can cache has apple. Let's do it. So we have another h, ff, 55, 55, and let's set up h here. Mem set h 0, -1, and size of h, and we do it here. So if HUV larger or equal to 0, we return HUV. And here we cache it, UV equals 1. And for this line, it's equal to 0. Let's see. Okay, I think the speed is similar. Okay, and I think that's it for this problem. And thank you for watching, and see you next time.